Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about swap injections. Swap is nothing but exchanging the nibbles. So lower nibble will be exchanged with the higher nibble. This is called swapping. So swapping means, look at this diagram. So this is the higher 4 bits, this is the lower 4 bits. So once if you perform swap, these lower 4 bits become a higher upper 4 bits and upper 4 bits become a lower bits. That is, lower nibble becomes higher nibble and higher nibble becomes lower nibble. So this is the operation of swap instruction. So swap instruction can be applied only for accumulator. No other registers will be allowed. So look at the instruction swap A. So that means it swaps the content of accumulator. So accumulator, if it is an 8 bit, we take it as a split into two 4 bits. There is a lower 4 bits and higher 4 bits. Look at the example for a get better clarity. Look at this. Move A comma has 72H. That means the 72 hexadecimal data immediately moved to accumulator registers. So after this instruction, accumulator becomes 72. So this is the actual instruction. After that, look at this. I am going to perform swap A. So what happens? So the lower nibble is here. Look at this. Higher nibble is 7. That is 0, 1, 1, 1. This is lower nibble 0, 0, 1, 0. So what happens once I perform a swap? This lower nibble 4 bit will go for a higher 4 bits and higher 4 bits become for a lower bits. That is, lower nibble becomes higher nibble and higher nibble becomes lower nibble. So after swap, what happens? This 2 becomes a higher bit, 7 becomes a lower bit. Look at this. After this, A becomes 27 because lower nibble have a 2, so higher nibble becomes 2. And then here higher nibble will be 7. Now the lower nibble becomes 7. So after swapping, we get a 27. Look at another example. I am moving 45 to accumulator. So move A comma hash 45. So after this instruction, A becomes 45. I am performing swap A. What happens? This lower nibble 5 becomes a higher nibble and higher nibble 4 becomes a lower nibble. Look at this. After swapping, the data becomes 5, 4. This is the lower nibble 5 becomes here and this higher nibble 4 becomes a lower nibble. So before that, it have a data of 45. After that, it have a data of 54. So next will be a rotate and multiplication by division. So we know that rotate operation, we can perform rotate left or right operations. So here we can use it as an equivalent multiplication and division operation. So note that shift left, that is a left shift operation, is same as multiply by 2. So if you are performing a left shift of any data, then that will be equal to multiplying that particular data with 2. Similarly, shifting right becomes a dividing by 2. So if you take any data, again if you perform a right shift, it is equal to dividing the data by 2. Look at an examples for a better clarity. Look at this here. Move A comma hash 3. So A will be moved with 3. That is a 3, that is 0, 0, 0. 0, 0, 1, 1. This is the actual data 3's. Now I am performing a clear C. So the carry flag will be cleared. C becomes 0 because we are performing a rotate left through carry or rotate right through carries. So the data should not be affected. That's why I am performing a clear operations. Now I am performing first operation RLCA, rotate left through carry accumulator. Actual data, look at this accumulator is 0, 0, 0, 0. There is a 4 word, it will be 0. Again 0, 0, 1, 1. So what happens if I perform a left shift one time? So what happens? So this 1, 0 will be go for a carry flag and carry flag data will be inserted here. Look at this. So what happens? Actual data will be, so this data, that is a D6 go for a D7 and then this. So here look at this. We have 6 zeros, so 1 0 will be removed. Remaining we have a 5 zeros followed by 2 ones and then carry flag data will be inserted here. So this MSB bit go for a carry flag. Look at this. So here we have 6 zeros. Once shifted we have a 5 zeros followed by this 1 1 and followed by carry flag data. So look at this. So what happens actually, this is 0, 0, 0, 0 followed by 0, 1, 1, 0. So 0, 1, 1, 0 will be 4 plus 2. So that is equal to 6. Now again I am performing a left shift one time. So what happens, look at this, RLC A. So what happens, again the same data will be left shifted one time. Here also now we have a carry flag equal to 0. So what happens, look at this. Here we have a 5 zeros, 1, 1, 0, 0. What happens? This 0 will be moved to carry flag. Remaining data will be retained here. So actually 5 zeros. Once we remove this 0, remaining we have a 4 zeros. So look at this, 0, 0, 0, 0 followed by 1, 1. So this is actual 1, 1. We have this 0 and then another 1, 0 that will be comes from a carry flag. Look at this value, 0, 0, 0, 0. This will be 0. 1, 1, 0, 0. So what happens? This is 8, this is 4. 8 plus 4 will be 12. Look at this. So actual data is 3. So one time if you perform left shift, it becomes a 6. There is a 3 into 2 will be 6. Again if you perform left shift another time, so 6 into 2 that will be 12. So each time it will be multiplying with 2. Look at this, I am performing a rotate right. So what happens actually if you perform a rotate right, it will be equal to divide by 2. So look at this, RRC A. So what happens, actual data is 0, 0, 0, 0, 1, 1, 0, 0. So we have a 12 here. So we are performing right shift. So what happens, so this data will be go for a carry flag. So carry flag data will be inserted here. Look at this, actually here we have a 4, 0 followed by 1, 1, 0, 0. So this carry flag data 0 followed by these 4 zeros followed by this 1, 1, 0, 1, 1, 0. So this 0 go for a carry flag. Now the data is 4, 0 will be 0, 0, 1, 1, 0 will be 6. That is divide by 12 divided by 2, that will be equal to 6. If you perform again one rotate right shift, what happens? Again this 6 is divided by 2, now the data becomes 3. So not only 3, if you take any data, if you perform a left shift, so it will be equal to multiplying by 2. If you perform right shift, it is equal to divide by 2. Thank you.